We are recording. Welcome to the evening of Python coding. Um, Today we have a very nice occasion, very important for me. There is a library called Prefect that I learned about a few years ago, and I'm very excited to uh, to get someone from the company to explain what Prefect does. Anyone who's interested in a lot of computing power, this is, as far as I know, the leading company, the leading library today. I may be wrong about this. Maybe someone will correct me. But Kevin Kho, we're gonna explain exactly why I'm thinking like that. So Kevin, go ahead and tell us why, if I'm right or if I'm wrong.
Yeah, definitely. I'll start presenting. So nice to meet you all. I'll just share my screen first, real quick here. I have
Yep.
some slides.
But am I right?
Um,
Like it's the leading company, it's a leading tool today to deploy computations on cloud environments. Is kind of correct the announcement?
yes, yeah, but we don't host compute. You have to bring your own compute. So you bring your own DAS cluster, right? But yes, we are here to for the deployment of your data pipelines.
Yeah.
So yeah. Hi everyone. My name is Kevin Ko. I work for Prefect, and Prefect is an open source project, and we're gonna talk about Prefect today. So I guess I know there's like a lot of varying backgrounds here. So I guess if and well number like three questions I'm kind of interested, and I'll check the chat for. I'll move this chat here. Number one, have you worked with Prefect before? Number two, if not prefect, do you have you heard of stuff like Airflow before? And then number three, are you are you from a data background or just like a more general Python programming background? I think somebody wanted to speak. Dan, you can go for it.
Yeah. Then you can unmute yourself, and if you cannot, just put things
All
in the
right.
chat.
Yeah, I'm familiar with Airflow. We have some Airflow, and we do some data, but not as large as would need this kind of infrastructure, at least on my side.
Okay. That sounds good. And I'll talk about that more as we go on. So, this is meant to be interactive. If you're not so familiar, if you're not in the data space, I hope that this is still relatable. So at least like if you don't understand anything, just feel free to interrupt me. Um, and yeah, with that, we'll get started. Just can you see my screen well, Jacob?
Yeah,
Just
yeah.
making
I'm,
sure.
I'm recording it.
Okay.
You're good. Everyone's hearing
Okay.
you. Everything
Okay.
looks great.
All right. All right, so yeah, thank you for your answer, Dan. Anyone else, like, feel free to type in the chat, like how familiar you are with workflow orchestration or data or Python in general, so I can adjust my presentation. So yeah, with that, welcome to an intro to workflow orchestration with Prefect. I'll just a bit about me. I currently my title at Prefect is open source community engineer. My role is about helping our open source community use Prefect. So we have a Slack channel, and primarily my job is like 80% of my job is like answering questions in the Slack channel, like how to use Prefect, how to deploy data pipelines and stuff like that. And the other 20% is like stuff like this, like conferences, meetups, stuff like that, where I present about Prefect or workflow orchestration. Prior to Prefect, I was a data scientist for 4 years. And then like slowly and slowly, I kind of, moved up the stack. And like I started, instead of doing more of the machine learning, I started doing more deployments. And then now I'm more of an engineering role here at Prefect. Outside of Prefect, I also contribute to another open source project named Fugue. Fugue is uh, an abstraction layer that takes your Python code and brings it to big data compute like Spark or Dask. And then I also organize the Orlando Machine Learning Meetup. And since this is a Python meetup, I just want to mention that if anyone is at PyCon later this month, like feel free to message me and we can definitely meet up. I will be there speaking also, not about Prefect, but I'll be there. So for today, we're going to talk about workflow orchestration, just general definition. I think that at the very least, I hope everyone here walks away and being able to like understand like what workflow orchestration is, if not how to use Prefect. And then we'll go over a simple Python problem. And then we'll see how we can apply Prefect to it. And then we'll talk about like a full deployment. and then we'll just talk about some general um, prefect future stuff if we have time, if time permits. I also want to mention though, I know we are like DC Austin meetup. Prefect is actually founded in Washington DC. We had an office there before COVID, and then like after COVID, it all became remote. But there is still a large contingent of employees in the DC area, and a lot of our like philanthropic activity is around the DC area as well, like volunteering for soup kitchens or working with the library system to provide laptops, stuff like that. So we very much identify as a DC company. So yeah, well, let's start with workflow orchestration. So let's say you have a machine learning pipeline, right? And some people get confused about what the word pipeline really means. Really, it just means you have a sequential set of operations that maybe are interdependent, right? So if we're loading data from a database, and we have some job that brings it out to a Parquet file. A Parquet file is just like like a more compressed file format compared to CSVs. And then we get data from an API, and we combine everything into pandas, into a data frame, right? And then we perform some machine learning on it. And during that machine learning, maybe we are storing some information about the training jobs, like what was the accuracy, like these kinds of metrics. Or maybe we want to store some kind of plots, so we push out stuff to MLflow, which is that kind of registry for that. And then if our model performs well enough, we can deploy it as a API endpoint for production use, right? But if we look at this, there we can see that there are many like each arrow here really is an interconnected step. So what happens if the API is down? This is the most common. APIs can go down, like it intermittently, like the request may not succeed. So now we don't have the data for our data frame. Or what happens if the database is intermittently down as well? Maybe some emergency maintenance or something like that, right? So in that case, what happens is uh, all of these downstream operations will fail, right? And how do we manage those operations? Because like these are interdependent steps, right? So if we look at the places that they can fail, the goal is really that we can say, hey, the API is not working. Can we retry that? Or hey, the API is not working right now. Can we just skip everything and don't even try running this because it's just a waste of compute, right? So the goal is but the more general question is how can we handle failure? And failure meaning both the ways we know it can fail and also the ways that it can, like in the event like unexpected failures happen, like data comes in malformed. How do we handle those gracefully and with as minimal effort as possible, right? And the complexity just exponentially increases, especially as uh, modern data pipelines become more complex. So, for example, I'm a data scientist and I have my own project and I have my own data that I rely on. But then another team may share that same data dependency as well in their project. And now we have these like interconnected data pipelines, right? And how do we manage this growing complexity? How do we handle failure events gracefully? And you, at first, what you can do is say, okay, the REST API failed. Let's just retry that. Okay, the data came in malform. How do we handle checks around that? Hey, my model didn't converge. Maybe I can try, or maybe like I ran out of memory. How do I increase that memory, like, and then retry that job? So when we look at the ways that we have to code against failure, and we're gonna see this as we go through the example, more and more you're gonna find that the the engineering effort. Dan is asking a question. How do you build a data pipeline? We'll use Prefect to build a pipeline today. So Prefect lets you build pipelines, but we'll talk about that. So uh, when we talk about all the ways that stuff can fail, that's what we refer to as negative. I mean, when we talk about engineering against failure and making code paths to handle failure gracefully, that's when we talk about that's what we label as negative engineering. So these are stuff like, hey, handling failure gracefully, or handling n- or how do we send notifications? How do we get data into the pipeline? I was muted. Never mind. Or let's say observability did not how do we get observability into the failure, or let's say there was some failure path, uh how do we handle that failure? Maybe we take another code path in that event, right? So the reason prefect was founded was because 90 I mean, I hope this number is decreasing, but back then, 3 years ago, when Prefect was founded, it was very common to hear that 90% of the engineering time was spent on negative engineering. So the thinking is that, hey, if we can eliminate the need for negative engineering and bring it down to 80% or 70%, then we can double or triple developer productivity, right? So that's the goal of the goal of Prefect is to eliminate negative engineering. So what is Prefect? Prefect is a open source workflow orchestration framework, so we can build pipelines with Prefect. Before Prefect, though, there were stuff like Airflow, or maybe the most basic form of a pipeline would be like, hey, I'm gonna schedule job one at 12 noon, and I'm gonna schedule job two at 1 p.m. And then I'm gonna schedule, and then that effectively is some kind of way to schedule your jobs that move data. And then, but the problem there was that with the lack of sophistication there, the problem is that, hey, if that noon job failed, or if it goes over 1 p.m., what happens to the 1 p.m. job, right? And that would obviously fail because it doesn't have its upstream dependency. So you needed a way to actually define the full workflow and to define the actual movement of the define the full workflow, and also manage those dependencies, right? And that's what workflow orchestration is about. So we are open source. We are on GitHub. We currently have 8,700 plus stars. And then the Slack community, which I manage, has over 15,800 members right now. So Prefect is Python based, first class on Python, designed for the modern data stack. And when we say designed for the modern data stack, we mean to handle the scale, like big data on native, the Pi data stack, like but also with big data with Dask, right? So we look at Dask as the way to scale pipelines out. We have a very active community, even if you just want to come and just ask questions about data engineering in general. How would you're very welcome to join the Slack community. We have currently have two offerings, but this is not really important. But we have what we call Prefect Cloud and Prefect Server. So this is Prefect 1, and this is what Jacob demoed a couple months back. But we are now in Prefect 2. So Prefect 2 was formally announced, I in maybe 6 months ago, and we're now in the beta of Prefect 2 Cloud, 2.0 Cloud. So we're going to demo Prefect 2.0 today. There were a lot of quality of life enhancements in Prefect 2. It should be intuitive for people who just know basic Python, and you should be able to pick it up as well. The the barrier to entry has been significantly reduced. So we'll talk about Prefect 2. It's free to try as well. We're on beta right now. We plan to hopefully get something production ready maybe at the end of this. At, we're gonna remove the beta label maybe at the end of the quarter. But if you need something production ready, like right tomorrow, Prefect Cloud 1.0 is available to you. Although I'm not gonna cover that today. But you're very welcome to email me afterwards or talk to me afterwards if you're interested in Prefect 1 as well. So that's just what I would. Orion is the name for 2.0. Core is the name for 1.0. So we're talking. When I say Orion, we're going to be talking about 2.0 today. And this is just the hello world. But before I get there, there's a question from Jessica. She's new to Python. Are there any trainings or bootcamps that I would recommend, or beginner groups that I would recommend? So to this, I want to say that I used to teach in a boot camp as well for data science specifically, and the boot camp name was Thinkful. I'll say though that with the wealth of knowledge out there right now, I wouldn't say you necessarily need a boot camp as well, and I think there's a lot of free resources that can help get you started. And I'll type my email in the chat. You can all connect with me afterwards, or you can add me on LinkedIn. So with that, we have our most basic Orion code, right? So the goal here is this is just the hello world code. We're gonna really dive more into this, but this function is just native Python. And all we do is we have to add this task decorator. And then now that we have it as a task, we can then use it in a flow. And the rest of this is just native Python, right? And then you can just call this flow, and then it will run as is. So prefect one was not this elegant. There was like a lot more adjusting to get your code into this shape, and that's why prefect two aimed to be as Pythonic as possible. So with that, we will get started with our sample flow. So here is our sample, what we're gonna do. I have a link here. I'm gonna make this bigger actually. So I have a link here, and I'll just make this a markdown cell. So I have a link here, and this link is a shoe on Nike. And what I'm concerned with is this price. There's this price, $150. And what I want to do is I want to make a daily job that will check this to see if the price is below some certain threshold. And then if it's below, like, let's say I'm interested in this shoe, if it's $120, if that price is below $120, I'm gonna send myself a notification. Okay, so here's what we're gonna do. So those more familiar with Python, we will use beautiful soup to actually get this number, right? So what we have to do is from beautiful soup, from BS4 import beautiful soup. Oh, sorry. And if anyone wants to like follow along coding, the dependencies that I will be using are basically beautiful soup. I think this is a beautiful soup. I'm not sure though. Beautiful soup for web scraping. But more importantly, the prefect one is you need to install the 2.0 specifically. 2.0, this is the version I'm on right now. So we're gonna import beautiful soup, and what we're gonna do is get this price. So I will also need the request library to make that to actually load the page, right? And then what I'm gonna do is I'm gonna set the URL equal to this, and I just need quotes around it, so it's a string. So now in order to open the page, what I have to do is I will do request.get and the URL, and we're gonna get the text. And then from there, what I have to do is use the soup object, beautiful soup, and I'm gonna pass in this page, and I'm gonna say HTML parser. So this is gonna read the HTML of this page. And now on this side, in order to identify this, what I need to do is inspect this. And it might be a bit hard to see, but the important thing is I am, maybe I can just copy this and bring this to Jupyter so that I can make it bigger for you guys. No, that didn't work. The important thing is that there is this class. So this price is wrapped in this div, and this div has a class that's called product price. So I'm gonna use this product price as the identifier for this, and then we're gonna get that price tag, right? So what I have to do is price, I'll just say price is equal to soup.find, which is this beautiful soup object. And then I'm gonna say find that div that contains the class product price. And then we'll get it as a text. And then maybe I can print this price already, and we'll see if that works. So let's hope this works. So we have $150. And what we're interested in doing is the problem with this price is we can't really compare it, right, to like actual numbers because it's in a string right now. So what we want to do is we want to make this an integer. So what I'm gonna do is since this is a string, I can just index it, I think, like this, and I will just confirm that. Perfect. So I can say price equals price, and then I can convert this to an integer. And I think that should be good enough. So now I can say, can call this, I can wrap it in a function, get Nike price, and this takes in the URL. And then I can return the price. And then to test it, I'm gonna get this guy, and I'm gonna say get Nike price URL. So I can run this, and I can, I need there, and then we get our 150. Okay, if there are any questions, just let me know. But I hope that's clear. So the next part is we know we have our price now with this guy. What we want to do is if I do something like price equals get Nike price URL, I want to just compare, hey, is this price greater or I mean less than my budget, right? So I'm gonna define a budget. And now I can do if price budget less than or equal to budget. I'll just do a print for now. So print, and then we're just gonna do a string buy the shoes. Otherwise, we go to the else and we say don't buy the shoes. F. Oops. Don't buy the shoes. Okay. So, and then so this should work. And now again, what I'm gonna do is actually wrap this in a function to make it parameterizable. So I'm gonna say this is the compare price, and it takes in a price and the budget. It's budget. I'm sorry. And then we can leave it there. And then this budget will come in, and this will come in as well. So now it should just be like this. And I'll move this up. And then from there, I can say, I'm gonna run. And then to there, I'm gonna just test compare price 150, 120. Okay, so this is working. And the last thing I'm gonna do is just use both of these inside, I mean, in this like kind of like main. So I'm just gonna say like main, and then this takes in the URL and the budget. And then from there, I can just say price equals find get Nike price of my URL, and then compare the price of my price here and the budget, right? And then now I should just be able to say budget is 120 for this, and then I can say main URL budget, and it don't buy the shoes. So this is my basic Python script. If I haven't been paying at, one sec, I pressed something and it's like, okay, sorry, the chat is here. Okay, so Mr. Oh, beautiful, thank you. So Dan is saying the dependency is beautiful soup 4. This, I just want to say, this really throws me off because like you install this, but you import this, right? So it's very hard to know what the package is, but thank you, Dan. The question from Sherry is, do I want to change the import from beautiful PS4 import beautiful soup to this? The answer is no. It's just a difference of the package name and the class inside this. Like this. As far as I know, it's the only library that like you install this, but you import it differently. But this is right. This code is right. It's working. So we're gonna just copy all of this to a Python script. I'm gonna make a new script here, and I know, and we're gonna just copy all of these guys, and this is how you use it. And then we're gonna save this as let's say like the Nike script.py. And just to confirm everything is working, I am in this. I have the same environment here as the Jupyter notebook, so I should just be able to do Nike script.py as well, and then I should just get some don't buy the shoes. So now I have this, and if I ask you, okay, how do I run this every day now? Oh, okay, yeah, thank you, Dan, for the comment. Um, so we have yeah, we have our Nike script, and what we're interested in is how do I run this every day? And naively, what you can do is you can do something like import time dot sleep, while true, time dot sleep, and then you put like, let's say for 5 minutes, I'm just gonna say like 300 seconds. So now this, and I move everything. So now if I do something like this, everything will run. Um, this whole thing will run every 300 every 5 minutes. But then, so this is the most basic way you can deploy, and then I can like maybe get a small box on AWS. I can just put the Python over there, and then I can just run it like that. But what happens then if like this is a request, right? So what happens if there's an intermittent hiccup with the internet, or like the page did not load? This will all break, and this will all error out, right? So the so at the very least, what we're interested in is having a prefect handle some level of handle that kind of like recovery, right? So what we can do first is wrap this in a task like this and then the um, the task will give us retry. So I'll say from prefect import task flow, and then one sec. I just need to know the syntax because it changed from 1 to 2. Um, okay, so here on under task, I can just say retries equals 3, retry delay seconds, and I can just give this like 30 seconds. So now with just this line of code, if ever this fails, it will just retry until it hits the maximum number of retries, and then it will actually fail the task, right? But so the semantics of workflow orchestration are task and flows. So this main, I need to now make a flow. And inside this main, so this main is a flow now, and it's going to use this task. And then I am also going to wrap this in a task. So now that I have these as tasks, that's all I need to bring it to prefect. And then now what I can do is first I'm gonna just show like what happens if I call main. I'm gonna call this the Nike flow. Name equals Nike flow. And what I need to do is I need to supply the URL and the budget. Let me just get the URL again from this. So main URL is this, budget is 120. And then now I can just run the script again. And you should see something different. So what happened here? By wrapping stuff in the task over here and bringing them into the flow, we got significantly more. This was the previous. This was without the decorator. This is a Python decorator, just in case someone's not familiar. And now that we did that, we got all these logs, right? So
you might want to explain decorator for a second. We have a bunch of beginners here, so just explain.
Okay. Yeah. So here we without the decorator, we are defining a Python function, but the decorator takes this function that we define and modifies the behavior in some way. So in the case of prefect, by adding the task decorator, we are adding some functionality around logging. And along with that, notice here, our decorator takes in the number of retries. So it's this, by wrapping this function here, with this decorator, we're adding some more like logic, like before or after the execution of that task, right? So Here, what we're doing is like now this decorator is going to handle that retry logic for us, right? So now that we did that, notice that we didn't just get a simple print statement. We got a bunch of logs, right? And these are the logs for the Nike flow that we defined over here. And here, what we're gonna see is, hey, it created a task run for the get Nike price, which is our first task over here. And then, hey, it got created another task run for compare price. So it did something here again. And then it finished in state completed. So it did something. Now, what there's one other thing. So this is our actual flow now, and these are the parameters of our flow. So if it's just like a normal Python function as well. What we can do is we can run this again, and the flow will, I mean, like we are just changing the parameters that go in here, right? But that's not the cool part about Prefect 2.0, right? What Prefect 2.0 lets you do is provide validation here. So for example, I'm going to annotate this as a string and the budget as an integer. And I'm going to corrupt something, right? Like this URL, I'm going to make it an integer as well. So this should obviously throw an error. But what Prefect does is it tries to validate to see, hey, is this a string that can it be made a string, like the thing that you passed in? Sorry, not sorry, that didn't work because the 150 can be made a string. I need something. Let's do it on the budget instead. So the budget. Oops, sorry. I need to make something that cannot be made into an integer, right? So I'm gonna say a. So now I'm gonna run this, and you're gonna see, hey, nothing even ran because when it created that flow run, the parameters were not valid. So this thing won't even it won't even try to execute this because it already failed the check here, right? So you see this received invalid parameters as failed. So by doing this type validation, we can already avoid expensive computation and just by making sure that our parameters are correct. So that's pretty much that's a bit it on the flow side. How complicated? George is asking how complicated can these tasks get? Could we have it handle errors differently? So these are just normal Python functions, and if you want, you can have the actual try except logic in here as well, right? Like the try here and then except, and then you can handle your errors differently that way, right? So there's nothing stopping you from doing that inside the task. Prefect 1, though, at the moment has more like, hey, if there's this error, do this, but Prefect 2 at the beta right now doesn't have such detailed functionality. But we're not quite done yet. What I want to show is that when we talk about workflow orchestration, normally we have multiple components that we talk about. We talk about there's normally a UI component where you can see the status of all of your flows, and then you interact with that through an API, right? So actually, Prefect 2.0 is very lightweight, and it ships with a UI where we can see this. So what I'm gonna do is type prefect Orion start, and it gives me this URL, right? Check the dashboard at this URL. So what I'm gonna do is make a new window and navigate there. And you're gonna see that this is because, okay, what we're concerned, this is, I was testing earlier, so I had something on the schedule. Actually, I'm gonna delete that so we don't have the scheduled stuff right now. And it should clear this like yellow stuff. So we should just focus on the actual, I guess, never mind. But what we're what we're interested about is remember the validations that failed. This you see this Nike flow is named platypus. Hot platypus is the name of this flow run over here. And similarly, if I go to one that succeeded, let's go to hypersonic. No, this was an error. This vagabond tiger, which succeeded. Sorry, it might not. So vagabond tiger we're looking for. If I go to vagabond tiger here, we see that it completed, right? So now if I navigate into vagabond tiger, I can see the logs that were generated during that flow run. I can see what the tasks were. So we had the get Nike price and then the compare price. And then inside this plot, this is the plot of like what happened during our run. So if I go inside here, you can see it's not too interesting, but this is our new visualization. You can see that, hey, the get Nike price task succeeded. It passed some data to compare price, and then the compare price succeeded as well. Dan says looks very much like Airflow. So okay, that I forgot to mention this. So the prefect founder, he was part of the Airflow maintainer committee. So for people who don't know, Airflow is the like most popular orchestrator, like by name right now, right? So our founder at prefect Storytime was part of the Airflow maintainer committee, and at one point he had the third highest commits in Airflow. Prefect stems from a list of changes that so prefect stems from a list of changes that were supposed to bring Airflow to 2.0, but it was rejected, and that's when he went on to create prefect, right? So Dan is saying AWS offers managed Airflow. So that is true, and we manage the unoffered service as well, right? And the right now though, so Dan, actually, I can talk about the differences between prefect and Airflow are, but I'm not sure that it would resonate well with this crowd. But I want to point out that this is all running locally. This is all in your local environment. You didn't have to spin up any service to test. It's very Pythonic. All you have to do is call this main at the moment. And oh yeah, thank you, Dan. So we didn't have what we just did was we just define our flow, and then we just have to run it, and then that is in effect of a monitored flow run with observability attached to it. And then we spun up our local server, and now we can interact and see the history there, right? Um, and if there are a bit more like beginner questions, a bit more like people who are not familiar with this as much, I know we have a general Python crowd. I'm happy to answer more questions as well.
Yeah,
Also,
Kevin, if you can go back and explain what happens if you don't put those decorators. The system should still run regardless. But what's the difference between?
So let's go back to that. Let's take out. I'm just commenting the decorators, and I'm calling this main, right? What happens is I'm gonna stop my service first. Oops, sorry, I didn't. That's what happens, right? We just have our, hey, it just ran as normal Python. But in the moment that I remove these decorators, then the moment I remove the comments, then it actually becomes a monitored flow run. So now we have gorgeous chinchilla as our latest flow run. And if I spin up my server again, and I go to that UI, I should be able to see gorgeous chinchilla just happened. So it should be down here. Not seeing it. Sorry, this is my bad. I have too much. Maybe I can use the filter here, and I can say give me I'm gonna add the flow run, and the flow run by name, and it was score. I'm just gonna copy paste this. Look, I want to find gorgeous chinchilla, and I want to apply this filter. So now I have gorgeous chinchilla over here, and this is the one that just ran, and this is the monitored one, and then here we have our individual tasks, right? So I also showed you that we can just use the filters over here. Actually, that's what I should really just do. I should just remove I should just make a Nike flow filter over here, and then just add that and apply it. And now we have all of the runs that I've been doing like during this hour. And then you can see that, hey, 2 of them failed, 3 of them succeeded. So you get your history in this timeline. And then these are also filters. So the default filters are, hey, show me the run history of the last day and the next day. And then you get the some statistics on the runtime and lateness. So one of the biggest requests of Prefect 1 was like, hey, I'm only interested in like flows that failed maybe. So can I filter by state? Or hey, I'm only interested in like, I want a dashboard view of like these 3 flows, for example. So what you can do is you can apply filters for those, and then you can save using this. You can save that search. So now you have this customizable dashboard that you can like select between these list of filters, and then you can filter that view that you want to see, right? Whether it's only failed ones or only late runs or like runs with a certain name, right? So checking the chat again. Yes, Dan says so. Airflow has problems with scaling. So one of the thoughts behind Prefect was the granularity of a task, right? So in in Prefect, like this basically just ran as a Python script, right? Whereas in Airflow, so one of the things we did here is you see this price was the output of task 1, and we put it into task 2. So this is something historically that's hard to do with earlier orchestrators. Like how do you pass this price to here? So us, because of the granularity of the task level, it's more similar to like a Python script. So now this is just passed like native Python. So in Airflow, you actually have to persist it somewhere, and then the downstream task has to retrieve it. And it was our CEO who wrote that mechanism, which is called XCOM. So one of the things that really motivated Prefect was first-class passing of data and support for like really like data science workflows. So yeah, I still have a bunch question. Sorry, there's a question. What is it called? How do you spell XCOM? XCOM. I think it's like the, yeah, yeah. But that's yeah. Dan is right. Thank you, Dan, for the clarification. That's Airflow. So what can we do next? The next thing that we are interested in is actual deployment. So what I showed you here is like how to define your flow as code. And now we are more interested in like that, like, hey, how do I run this every day now? So something really beautiful about the way that current Prefect is set up is that, hey, if you have this, for example, you have this like function call, and remember that when we were just calling this, we were getting stuff. So now you just need to schedule this script, right? And you can run it with cron. You can even schedule the script with Airflow. Actually, like you can schedule the script with anything, and it will still run Prefect under the hood. We using that like API that's we call it ephemeral, but basically there is this API under the hood that's communicating with a SQLite database and persisting the state of the flows and tasks, right? But if that might be a bit too much detail. What we're interested in right now is, hey, I have this code right now, and I want to deploy it to run every day. So in Prefect, what we're gonna do is we're just gonna say from prefect.deployments, and we have to make our own deployment spec. And this deployment spec is the abstraction that takes in all of the configuration about how we deploy it. Hey, we're gonna deploy it. Do we run it on Docker, on Kubernetes? Do we run it locally? So we're gonna say we're gonna import the schedule as well, which we'll use to orchestrate the schedule. I mean, to put this on the schedule, and then import time delta. And then I'm just gonna copy this deployment spec, Nike shoe, and then we want to take in this main flow. So I'm gonna say, hey, this is the main for our schedule, I'm gonna say interval schedule, run every minute, and then I'm gonna put a tag, and then this sub-process flow runner, I have to import that. Here we go. So this sub-process flow runner is the default. This is just saying, hey, run this as if it were a Python. But then this is a script. But this is the one that can take, hey, you can have the Docker flow runner, which will then spin up an image and then run your flow inside the image. Or you can say, hey, Kubernetes flow runner here, and then you can configure it to run this flow as a Kubernetes pod, right? So we're just going to use the default sub-process flow runner, which is just local. And then what we're gonna do is register this deployment. So I'm gonna comment this out, and I'm gonna create this deployment. So I'm gonna say prefect deployment create Nike script.py. And what I should see is that it created a deployment, and I can inspect that now with the command line just to see that, hey, what were the details of this deployment? So there's the main thing is the schedule, the interval, and then when it was created and the name and stuff. So now I created this deployment. I want to see, hey, how does it look like in the prefect UI, right? So I'm gonna do prefect Orion start again. You can leave Orion start on, by the way. I just didn't, but you can, and it's probably preferred. And now we have this deployment that I want to filter on this deployment. So I'm gonna say filter on this deployment named Nike shoe, and I'm gonna apply that. And notice this deployment has all of these scheduled runs. So we schedule the next 100 runs in advance, and these are runs that are all scheduled. But why is it that these are scheduled? So in Prefect, when you're actually bringing stuff to production, you need an agent that will look for jobs and then find jobs and then execute them, right? So the first thing we need to do is to make a work queue, and I'm gonna name this as a demo. And you can filter this work queue to say, hey, only run for certain tags. Like for example, we had a tag in our flow. It was called demo. Like we could say, hey, only run like stuff with the demo tag. Or you can say, hey, this is the Docker work queue, so only run stuff that's going to go to Docker. But we're not going to apply any filters. This will pick up all of our work. We're going to save this, and it gives us this command that we can use to start our agent. But before I do that, what I want to do is I'll just use a new command line actually. What I want to do here is I'm trying to make this bigger. Okay. What I want to do here is prefect work queue preview, and then that ID that it gave, right? So now I can say, hey, what's the work that's going to happen in this work queue? And then we have this deployment ID that's associated with the Nike shoe deployment that we just had. These are the names of the flow runs that are scheduled, and then the corresponding run IDs and the times of the schedule, right? So now that I have this set up, what I can do is copy this command, prefect agent start, and this work queue. And now I'm creating an agent that can pick up work from the work queue. So now we have stuff running. And if I go back here, we should see that, hey, like we're getting, there's some failures, but oh no, sorry. We're concerned about this Nike shoe deployment. Well, that's right. I don't know what these failures are, but the important thing is now we have stuff that's running. That agent is now picking up code, running it every minute now. So now we can say, hey, run this script every day. I have a feeling the failures are related to just trying to open up that page too many times in such a short amount of time. But the important thing is we have stuff like here, the agent just picked up another flow run. So the agent is looking at prefect the prefect database and API. It's polling every 5 seconds, and if it finds a job that's scheduled, it will pick it up and then execute it. The last thing I want to say though is I will just show this briefly. Is over here. I'm gonna take out I'm gonna just recreate this deployment so that it doesn't. I'm just taking out the deployment. Okay, I'm just gonna take out this. Ignore the deployment. What I want to focus on is this flow over here, because a while ago I showed you that hey, I have this task and this task, and I brought them into the flow. But something that's important in Prefect is actually you can write native Python code here, right? So for example, if I did something like this, URL or price is easier. So price budget equals budget minus 10, for example. And then I can say print new budget. This can actually work. So we are not confined. And then in fact, I can even just remove these task decorators. And now it's just native Python code inside my flow. And I can run this and it will still work, right? So, sorry, I didn't call main. So we have a flow run and they're just not tasks anymore, but we have native Python code inside the flow. So at the bare minimum, if you want to get started using prefect and putting something on a schedule, all you have to do is wrap all your code in some kind of main block and then put a flow decorator on top. And that's it you need. And then now prefect can monitor that with observability, and you'll find that also in our dashboard. So yeah, Dan has a question. Does this write a Python script? Could you elaborate on that, Dan?
So this goes back to when you were building the deployment and you declared the deployment in Python code, and then you ran a command to deploy it. And I was like, so is that the equivalent of, building a
Yes.
Airflow DAG and copying it into the DAGs folder and,
Yeah.
etc.?
Yes. In effect, that's a registration against the API and database. That's exactly right. You can have it inside here, but I think in practice, what's going to happen is you'll actually have it in a separate file. So if I copy this and I throw it somewhere else, I can point to it by saying flow path instead. And then from the flow path, I can give my the path to where that flow exists.
I see. So the file that has this code in it stays where it is.
Exactly. Exactly. Yes. So there's a.
So, and if you don't use it, like out of the box, it seems like suppose you were to run this file from cron, you still get the benefit that you can see the status of the flow in a GUI, and you're still going to get retries if there's failure and things like that. And I'm asking, I'm not saying.
Yeah.
I don't
No,
know.
you absolutely caught on. We can be a glorified cron dashboard. You're right. Absolutely.
And so that's also great because it offers you a way to slowly evolve from cron to a workflow scheduler. You use the display component and you use the language integrated way to declare it. Like this is a lot more like Luigi in the way you write the code, but a lot more like Airflow in the way that it interacts with the architecture.
Absolutely. So one of the focus of Prefect 2.0, and our CTO did a demo of this last month, where he used cron to orchestrate this Prefect flow, and you get the dashboard with observability. So something that's been a focus of Prefect 2.0 is that incremental adoption. You can put as little as you need into the Prefect land, and we'll handle that for you. At the same time, you can make it as opt in. You can opt in all the way with wrap everything as a task, bring it to your flow. You can do all of that. It's totally up to you how much you want to opt in to the system. George, I see a question. Okay, sorry. I'm sorry, George. I didn't really get. So, okay. George's question is, if you have a task that fails a certain way, can you configure the task to not retry it? In Prefect 2.0, it's not a feature yet. I imagine it will be on the roadmap because it is present in Prefect 1. So in Prefect 1, I'll just this Prefect 1, unrelated to presentation today, but um, the Prefect 1 task takes in a state handler. And the state handler is some kind of arbitrary function. And it says like, hey, if this function, like if this hits a failure state, run this function, right? So you can do stuff like that. But there's also a new parameter that was just in the last patch. I forget what it is, but basically you can supply the types, and it's like this takes in a list, and you can say like value error or something like that. This exists where you can say, hey, for value errors, on failures with value errors, run this, but if it's a different kind of error, don't run it. You can do that in Prefect 1, but Prefect 2, not yet. You have to do that try except yourself inside the task. So here, like if this parsing failed, I need to say like try. I need to put the try except around it, right? So try, and then except, like some kind of error, like client error or whatever, SE, and then you put your other logic, right? You have to do this in Prefect 2 right now, but there's nothing stopping you from doing it, both in the task side, and you can also have, because we allow for native Python, you can have native Python thrown in your flow side as well. So now, for example, this is a bit different. I'm gonna go to I'm trying to open the one we were working on together. So for example, let's remember that these are tasks. Now I can have the try except and say, hey, price is a task. Can I see? You have to call dot result like this, and you're saying, so let me think a bit. It's gonna be like this. If price dot result value error, and then you can put your logic, or I mean, not quite. It should be like is instance. You get the point. But basically, what we're doing is we're just adding native Python here, and you can do something like this. Hey, if the price result is a value error, add some other logic. So you can still do that in the flow, or in the task you can add that handling logic. I do have just some quick announcements. Okay, thank you, George. Some just really quick announcements. I know we're a bit over, but I just want to say that Prefect is one. We have Orion docs. You can go to the docs here. You can email me. I'll leave my chat. I'll leave my email again here. You can add me on LinkedIn as well. Number 2, we are hiring for tons and tons of positions. Feel free to check the job board for sure. We have all positions across the whole, like sales, developer advocate, engineering, etc. And with that, thank you for having me. I know it was a bit rushed at the end, but I think we covered a lot. Thanks for the great questions and for being an interactive crowd.
Don't go away yet. Are there any more questions?
I'm not. I'm here. I'm here.
Before, are there any more questions for Kevin? Okay, I'll ask you a question unless someone else goes away.
Then once. Oh, good.
No, let him go first. It's like if someone.
Okay, go on then.
Not like I'm quiet. I'm sorry. If there are any other questions, I'll defer. So my question is about Prefect Cloud and how this scales up. Like, if you want to run Airflow, you have one server running the GUI, or maybe a couple, and you have the scheduler, and then you have workers, right? My guess is that Prefect Cloud doesn't run the jobs for you, but it acts as a distributed store and viewer for them, but I'm not really sure. And
Yeah. So this is where I said we'd have to get into detail and ask me later. But that is exactly right. So that is the difference. In Airflow, you have managed Airflow in AWS. Where's the code being executed? On Airflow, right? And what we find is that people who migrate from Airflow to Prefect say that one of the reasons they migrate is because of like they can decouple stuff and into several repos code-wise, whereas the Airflow setup encourages a monorepo. So in Prefect, everything is decoupled. I started an agent on my machine, but if we're on the team, I mean, like, but I can have an agent like on virtual machine A, and I can have another agent on virtual machine B. I can have another agent on a Kubernetes cluster elsewhere. So all of the compute is decoupled, and it works by those agents polling the centralized like server for work, and if they find work, then they execute it. So we don't charge we do, like if you if you use a service like Airflow, you're kind of pass through build that compute. We don't bill for compute because we don't host any of your compute, and we don't see any of your task code. We don't see any of your code or data, which makes us like very like secure and like private by default, because like we don't see any of those.
Thank you. That's very clear. Thank you. Well, clear to me. I could also say for other people who are less experienced with this kind of thing is that what Kevin is talking about is uh, exactly clear. Like what you have is you have lots of different apps with lots of different scheduled tasks, and when you're really immature about doing that, there's no observability and no visibility, and or not cross team anyway. And there's also no ability to stop the pipeline if something goes wrong. You might have a cron job that runs at 12:01 a.m. and then another one that runs at 2 a.m. And the one that runs at 2 a.m. is scheduled and it just assumes the previous one worked, you know? And this is a very older way of doing things, um, you know, and that's what Kevin is saying is that this is the benefit of things like Airflow and Prefect is that you can declare that this job depends on this job, and one should be done first, the second one second. You can define how parallel it is, etc. And you can also make sure that it's observable.
Yeah, thank you for chiming in there. Yeah, yes, Jacob, if you had a question.
Yeah. So I want there are several things here
You're
that are
muted.
like,
You're muted.
oh yeah, sorry. There are several here things I want to hear here. So please separate some. You try to do things during the talk, but I wanted a bit more separation. So specifically, what is the main differences between prefect 1 and 2?
Yeah. Um. Yes, I can
And
share my
and
screen a bit
what's the
here.
difference between prefect and prefect cloud?
Yes. Okay. To share my screen and it like booted me out, I think. Am I
Yeah,
back?
I also experienced some problems communication. I
Oh,
can now see you. I cannot see anyone else, I think. Maybe I'll be back.
thank you, Dan.
Kevin?
Yeah. We
Okay,
ready?
I can
Yeah.
hear you. There's some communication problems, but I cannot see. But answer the question and we'll stop the recording. Then it seems that there's communication problems.
Yeah. So number one is that prefect one. So Airflow is synonymous to the concept of a DAG, right? And what we do is we define our tasks in this DAG, and during the execution of that pipeline, the tasks are then ran depending on upstream and downstream dependencies. So prefect one is the same. We inherited the DAG concept from Airflow. Prefect two is DAG has has no defined DAG, right? So, oh sorry. So Sherry is asking, can I define the DAG? A DAG it stands for directed acyclic graph, and what it just means is like if you have a couple of jobs and you just draw the arrows and you go like from upstream to downstream jobs, that's a DAG. It's a graph that just has these are the jobs, and I'm just pointing the dependencies, and I just have the arrows. So it's represented as a graph, right, of your jobs. So the workflow orchestration space has been synonymous with the concept of the DAG, right? So we had Airflow, and then Prefect inherited the DAG as well, and we even have Dagster, a company that really relies on the DAG. That bets on the DAG concept, right? And Prefect 2.0 makes the DAG optional, so you can make if you make a task, you make tasks and then you form a flow, you're making a DAG. But remember that we can just insert all of the native Python code inside the flow. So by doing that, you're not making any DAG. You're just making things runtime, like flexible for runtime. And during runtime, you build that DAG, right? So think about that even further. You can now have conditionals like if else. You can have infinite loops inside your flow. You can do stuff like while this condition is true, execute these tasks, and then the moment that condition is false, don't execute it anymore. So a big thing is that the DAG has been a constraint that people have often had to work around. So we eliminated the requirement for DAGs. And that's the premise of Prefect 2.0. The second question that Jacob had is what is the difference of Prefect Cloud and Prefect? So Cloud, what, yeah, I guess I did do a good job of explaining. When we talk about Prefect, you're talking about the Python package that you install and that you use to make your flows. And then Prefect is best run with a backend. So the backend is Prefect Cloud or Prefect Server, right? Server is you self-host, Cloud is we host, and that's for 1.0. For 2.0 though, it's the same thing where like we have Cloud 2.0 where we host, but you can do everything locally and you can deploy everything locally as I showed. You just have to pip install and the UI is there, the API is there. Like it's all complete. All the services are already there. So you can just pip install and run Prefect locally, or you can run Prefect on the cloud now, right? It's called Cloud 2.0. Because if you were using Cloud 1.0, there's just a distinction between old cloud and new cloud because they're a bit different. So that distinction is a bit important. But cloud is basically when we host the API specifically.
Okay. So now one more question, unless someone just.
You're still muted, Jacob.
Yeah, one more question. I'm muting myself so it won't be interference. But one more question, unless someone wants to jump in another one. But prefect the previous prefect, they used to have dependence on Dask. I don't know if dependence, but by default it used the Dask. Is it still the same in Prefect 2.0?
Yeah. And this is for Dan as well. The concept of prefect at its inception was Airflow semantics on top of Dask, and the reason for this is because Dask has like a scheduler, a millisecond latency scheduler, parallelizes tasks for you, has retries inbuilt. So how do we get the Airflow semantics of workflow orchestration and scheduling and upstream dependency, downstream dependency, and using that on Dask, right? And that means that Prefect then at its inception was built on top of this Dask concept. And for people who don't know, Dask is an open source distributed computing framework that lets you run like stuff in parallel, normally used for data frames though. So now Prefect was built on top of Dask, but then it also decoupled and like removed that dependency on top of Dask. And now Prefect 2.0 is not quite dependent on Dask, but for massively parallel scale, then you can introduce a Dask task runner in your flow, and Dask is the one that will massively handle that scale. That will handle that massive scale for you.
Thank you. Any more questions from anyone? Well, it seems everyone's quiet. Questions going once? Questions going twice? Oh, someone? It's a thank you. And
yes, Dan. Here for your questions.
go ahead.
I had a question about deploying the server. If you want to run a prefect server, Airflow was very opinionated. Like you have to use GUnicorn. You have lots of different, very specific requirements, so that you had to use like pip constraints and learn about those. And you know, is it possible to sort of say, okay, I want to run it inside something else, like I want to use Waitress or Fusion Passenger, or does it really want to be using GUnicorn or its own server?
Yeah. So what I demoed was just I did prefect Orion start, and the emphasis is getting that working. As long as you can pip install, prefect Orion start will work out of the box and spin up the server and appropriate services right on GUnicorn, right? So in that sense, that's abstracted from you, and it's not. You don't have to worry about like those kinds of like hosting, like API hosting kind of frameworks. But what you do have control over is like, hey, I want to run this on in a Docker container, for example, right? You could do that, and then you can have kind of like different. I don't know if you have different like containers with different dependencies. You could run prefix server inside. I don't fully know if that use case makes sense yet, but it's something you can do now that you could not do before.
I have one more question about environments in Prefect 2. So Prefect 1 was mostly agnostic towards operating system you're running on. I was running it on a Windows machine. Prefect 2 is the same, can run on all environments, or are there restrictions?
In the beta, there is some Windows incompatibility issues, but our goal is definitely to make it agnostic to the operating system you are running on. It should run on all. Yeah.
Okay.
I am also happy to answer questions about. I know. I mean, she had to leave, I think. But then, if you want to ask me about bootcamp or resources, you're just beginning with Python. Feel free to email me as well, or add me on LinkedIn.
Yeah. So if we get into those questions, not about Prefect, then I'll ask one more time. If there aren't any more questions, we're going to stop the recording. Once. Question is going twice. Question is going 3 times. Well, no more questions. It means that you answered everything, and we now perfectly know how to use prefect. So for this, we want to thank you, and please make some noise. Unmute yourself. There's some clapping. There's like.
Oh, thank you for being an interactive audience. You can email me at prefect if you're interested in trying prefect. I can help you with that too. You can also join our Slack channel over here. I answer the Slack channel. That's my job. Yeah.
Well, thank you. I'm gonna stop the recording. Don't go away. Thank you again.